Is it time? Yeah. Whoa, full room. We're just on time. Fantastic. Brilliant. Hey, good morning, everyone. Yeah, that's the sound coming from me. How you doing? How did you enjoy the first session so far? Yeah? It was a good session, wasn't it? Do you mind doing me a favor and all just wave and smile for my mother so that tell her that you're all such good people there? Woo! Fantastic. This is gonna go on Twitter, by the way. It's good to be back in Stockholm. I love Stockholm. It's one of my favorite cities. I actually plan on moving here at some point, but don't tell my mother. So, for the next 2 hours or so, I have 2 hours to speak, right? No? Yeah? Fantastic. I'm just kidding. For the next 50 minutes or so, I will give you a quick talk on container apps and Dapr. How many of you have ever heard of Azure Container Apps? Raise of hands. Fantastic. Oh my God, why are you guys here? How many of you have heard of Dapr, D-A-P-R? Not the one spelled D-A-P-P-E-R, which is different. Okay, that's good. So, um, this talk is actually, by the way, for those of you who don't know me, guys, I do see a lot of familiar faces. My name is Alex, for short, because I have a longer name. This is my stage name, Alex. I'm what Microsoft calls a most valuable professional, which is just a program, and the regional director, which is just another program. I do not work for Microsoft, thank God, so I do get a chance of actually bashing them whenever there is a need. But jokes aside, I actually do speak a lot at various conferences, community conferences and tier 1 conferences, just like this one here. And I do enjoy whenever we have a lot of interaction. So if at any point in time you have any questions, I would actually love to take them. So don't feel like you're interrupting, because you're definitely not. I want to make this interactive. And yes, we're also recording the screen, and I hope that my voice is also recorded, because otherwise it would be just annoying for 50 minutes to see a bunch of slides and some code, because there is code involved. But as I've mentioned, feel free to ask questions. I'm more than happy to take them. And obviously, if you don't feel like asking any questions right now, that's fine as well. We can take it offline during the breaks as well. So whenever I speak in a lot of cities, I also like to visit those cities. Here in Stockholm, I've obviously visited a lot of different places as well. And I also do, and I'm one of those strange guys who actually do enjoy a museum. And one of my favorite museums, some of you already know, is actually in Stuttgart, where there are two fantastic museums. One of them is the Porsche Museum, because, well, Porsche. And the other one is the Mercedes Museum. You may see a recurring theme here. The Mercedes Museum, however, unlike the Porsche Museum, doesn't emphasize that much on the brand, but rather on the industry, of the automotive industry specifically, of course, and the evolution of our society alongside with the industry. And it's a museum in a building which is in a spiral-shaped form, and it starts at the 5th floor, and as you go down, you go through, well, 150 years of evolution of the automotive industry. And it starts with this, a horse. And it's fun because there is a supposed quote from Emperor Wilhelm II, who supposedly said, "I do believe in the horse. The automobile is no more than a transitory phenomena." I do believe he was wrong, because 150 years later, we actually have quite a different situation. And then when you go on the 5th floor, this is the first thing you see right after the horse. And this supposedly is the first vehicle ever. Right there in the back, you might see that there is an engine. It's a 2-stroke engine, the very first engine ever equipped on a vehicle, on an automobile. And it is also called the grandfather's clock, because it looks like one of those old pendulum clocks. It literally resembles that. Now, I don't know about you, but this does not look like a car. I don't find it to be looking like a car. There's no steering wheel. The seating is interesting, to say the least. The thing that you see here in the bronze casket color, that is the tank engine. And you would buy the thing that you would fire the thing with from a pharmacy, from a drugstore. It was a different kind of a vehicle, let's put it that way. And then you had this. I don't know about you, but in my opinion, it feels like it is missing a horse. Again, not pretty much a car. But one thing you can tell is that they were testing things out. As they were evolving the car and as the evolution passed, they were actually trying things along, right? And they were trying different designs. This one was a different one. This was Well, if you would want to make an analogy, probably this is workload distribution at its best in a car. Because the people in the front were responsible for braking. The people in the back, passengers, were responsible for, well, the entire traction system and whatnot. And of course, it was so difficult to have so much distribution, they had to put it on tracks. They couldn't also steer it at the same time, because another pair of people would just mean a chaotic situation. Again, not the best car ever, but interesting. And then here's another automobile at the same museum. I took these pictures, by the way, but feel free to use them if you want. This, in my opinion, still feels like it is missing a bunch of horses there, right? It doesn't look like a car, but it is regarded as the third generation car ever built, and it obviously used combustion engines and whatnot. Again, no proper steering wheel. The chauffeur was actually there in the front, outside of the cabin, but it does feel more like a whole-spooled carriage, in my opinion, right? What you see there in the back, that's a cabriolet. If you ever wondered why the Americans call taxis cabs, it is this which actually started the word, cabriolet, which meant that the chauffeur was actually outside, but everything, there was no cabin, right? And they were just pulling and carrying people around in a so-called cabriolet, and that's where the word cab started from. And then you had this thing right here. This is called the vis-a-vis car, because the passengers inside the car and the chauffeur would be social. They would look at each other. Try to imagine this. You're trying to steer your vehicle, and you're constantly doing this because you cannot see. You have to lean all the time. It was crazy, wasn't it? But they were obviously testing things, and at some point, they did get things wrong. And at some point, they did get things right. Over here, they decided with the passengers in the back, all the way back. They were even looking back. Interesting. And then eventually, they got to something that does actually resemble a car, roughly 30, 50 years later or so. Now, this is a picture I came across roughly 3 years ago, completely by accident. It's a picture taken roughly in the early 1900s. The earliest assumption is that it is 1903 when this picture was taken. It's a picture from the Fifth Avenue in New York City. One thing you can tell is that Manhattan, the Fifth Avenue, Upper East Side, was as crowded and busy back then as it is today. But one thing you cannot tell from a picture is that it was also very smelly, because there were a lot of horses, right? So what's interesting about this picture, is that cars by that time existed for already 30 years or so, both in Europe and the US. And yet, if I would urge you to spot where the car is at, it would be pretty difficult. There's one car in the picture, though. Can you find it? Some of you did. Just one car. Now, you know what's interesting? It's the second picture I'm going to show you. 10 years later, fast forward 10 years, only a decade. Cars existed by that time, for 4 decades at least. And yet, within 10 years, everything changed. Because all of a sudden, it becomes difficult to spot where the horse is at. On the same Fifth Avenue, same springtime, same city. It's right there. So the question which I can ask, and obviously you're begging yourself as well, is what happened within those 10 years? Does anybody know? Come on, give your best assumption. Ford. Yeah, just one word, Ford. What was special about Ford? Did Ford invent vehicles? No. He was a good manufacturer. He actually invented the way we build vehicles. And you know what's interesting? The conveyor belt convention system that he actually installed within his factories is still used today. Obviously, with a lot of robotics and automation and AI and ML and whatnot, but that's a whole different story. But the concept, at least, that you would have one individual do a repetitive task over and over and over again meant that now you could actually distribute the workload of many individuals within the factory, which inevitably meant that the cars became simpler to manufacture, cheaper to sell, and also engineering-wise, they became much simpler to maneuver and maintain. And interestingly, 100 years later, give or take, we kind of use the same techniques and the same approaches and everything else in the car. Now, inevitably you're going to ask yourself, okay, what does all of this have to do with software and Dapr and Azure Container Apps and this and that? Now, I've been in this industry as a software developer for at least 2 decades, actually more than 2 decades, 2.5 decades by now. And one of the things I see recurringly is that we constantly speak about this thing which we either called SOA, microservices, there were a bunch of different names throughout the years, you name it. But one thing I can tell you is that microservices are anything but new. They're not new as a concept. We wanted microservices for many times now. And the whole idea and the whole pitch was that we wanted to leverage some sort of a design pattern which we can implement in all of our applications so that we can take advantage of the massive scalability capacity of applications and the cloud specifically to run our applications. But before getting our hands dirty, let's just cut to the chase. Developing all of these microservices is anything but simple. Because the reality is that even when you read Sam Newman's book, there are a lot of assumptions which are just hypothetical and idealistic, to say the least. In the real world, you're going to be a developer working on a bunch of different sprints, now wearing one hat, say, of the payment integration system, and then within the organization, a bunch of sprints later, you're going to have some new tasks that you're going to have to work on, and all of a sudden you become an expert in a completely different bounded context. And all of these integrations that you're going to have to work on as the same individual, I'm still Alex, I'm not going to be somebody else, I'm still going to be Alex. All of these integrations I have to do mean that I have to think about all of those NuGet packages, all of those APIs, all of those contracts. I have to discover them. I have to know that within my company, somebody else has developed another API which already does the thing that I'm actually planning on working on. And all of these means complexity, and that complexity, more often than not, moves over to the developer, which is no easy task to myself, right? The second problem with microservices is that there's a lot of specificity in code these days. We want to make services simpler, but then again, given the tech industry we live on today, me, the developer who loves C# or Node.js or Python, you name it, all of a sudden has to become an expert in Ansible and Terraform and ARM and Bicep and this and that. And by the time I know all of these, there's a bunch more that I have to learn. And eventually I want to write some code. Surprise, surprise. It's not all about your code. It's about your CI/CD and pipelines, and it's about this and that. And it's so much thing that you have to write even very specific infrastructure-specific code in your code that you actually stop writing proper code. And that's very annoying, especially with microservices, where things become smaller, and then you realize that the smaller they become, the more infrastructure you implement in your business logic. And that's just messed up. And then it's this whole idea of big vendors, even including Microsoft, Google, Amazon, you name it, who all pitch the idea that their service, their platform, their infrastructure, their whatever is cross-platform this, cross-platform that. They run anything, right? And that's a good marketing pitch. But let's face it, how many of you actually write on a single day in 5 different programming languages, right? You don't care about that. You just have one language which you love. The downside, however, is that with this marketing pitch, we tend to hire people within the same team who know a bunch of different languages, which might be a good thing, but then at the same time, there might be a bit of specificity again among the languages that we have to integrate in the same project. And this now becomes a contractual problem within our APIs that have to communicate one with the other. So for the past 12 years at least, I've seen a bunch of different approaches where all of these problems were solvable, but it was never perfect. And therefore, a lot of people actually go away from microservices and they try to figure out solutions regarding scalability and availability and discoverability and whatnot in monolithical applications. And I know these days we're using the monolithical word as a bad word, kind of telling that, hey, your application is a monolith. Sounds like it's a bad thing, right? But the world really literally ran on monolithical applications for decades by now. It's not necessarily bad. It's just unoptimized. Let's put it that way. Until something appeared, Dapr. And I know this may sound like marketing, and I'm anything about the marketing individual. But me as an enthusiast, as a tech individual, as an early adopter of a bunch of different things, I looked at Dapr 2 or 3 years ago, and I was kind of impressed. I'm going to tell you up front. The first thing that sold me on Dapr personally was the fact that it was pitched not only by Microsoft, but by some very smart people at Microsoft. So Dapr was an incubation project 3 years ago. And the program was actually run by Mark Russinovich. Anyone ever heard of Mark Russinovich? the CTO of Azure, very smart guy. Back in the day, he was actually delivering trainings at Microsoft as a non-Microsoft employee on Windows internal stuff. He also wrote the books Windows Internals. It's quite a thing to teach and train Microsoft developers on Windows about Windows, not being a Microsoft employee, isn't it? Anyways, long story short, he's a very smart individual. He runs the incubation program. He hired a bunch of very smart engineers to develop this thing that actually initially was rooted in Service Fabric. Who ever heard of Service Fabric? Yeah, don't we all love Service Fabric? There were some giggles. So the thing with Dapr, D-A-P-R, which is not the A-P-P-E-R, which is completely different, is that this is supposed to be a distributed application runtime. And the definition of Dapr is that this is a portable, serverless, event-driven runtime, which makes developing resilient, stateless, and stateful microservices easy. What's interesting about this definition is that literally every noun and verb and adjective has been very particularly chosen to explain specifically what Dapr is. So take any word here, and it literally tells you from a single phrase what Dapr does and it's supposed to be. And it literally does that pretty well. So the goals of Dapr was to enable developers, again, any language, because vendors love that, or any framework to write distributed applications, microservices specifically. So ideally, in an ideal world, it will solve all the hard problems that developers had when they were trying to build microservices applications. And we all have them, we all face them. And another goal about it is it was meant to be community driven. So open sourced from the ground up, right? So it would allow people to gain new contributions in the project, to gain new contributions. It would provide consistency and portability for a bunch of APIs. And a lot of big vendors using it as well. Even on their main webpage, they show Bosch and Zeiss and many others actually using them. Now, the building blocks of Dapr, and I want you to understand these building blocks, you don't have to use them. It's just a bunch of features that Dapr offers, and you can pick whichever you want. Is that Dapr would provide you service-to-service invocation. For those of you doing, for instance, microservices for a while now, you know that service-to-service invocation, especially on top of HTTP, is kind of a no-no in most scenarios, except for a handful of few, when you want some microservices to communicate with others, such as the BFF scenario. BFF does not stand in microservices for best friend forever. It stands for backend for frontend. And the idea is that you have one microservice which correlates all of the information to generate, for instance, a user interface from a bunch of other microservices which have completely different separate and discrete responsibilities. State management. Have a microservice which holds some data that is readily available for other microservices and governs that data, cleans the data, updates, for instance, a cache whenever there's a need to publish and subscribe. Whole idea of using a pub/sub mechanism, but rather than using service bus, like a native service from a given vendor, just use anything, right? And it facades that and abstract that's away as Dapr, right? And then you just consume messages without actually caring about the underlying tech. And I'm going to talk about these abstractions in a bit, just a bunch more. Actors, observability, secrets, the extensibility capabilities, just a feature of Dapr as well. And some of these may actually seem recurring or even repetitive if you're already using microservices and you're already leveraging things such as Istio or Linkerd. Yes, you already get some of these capabilities out of the box. So Dapr isn't here to replace them necessarily, but if you are leveraging Dapr, then you can actually put them alongside with your already running microservices and meshes. You know, I'm just going to do a quick parenthesis here. The whole idea with meshes and service meshes and sidecar patterns that we have in AKS whenever we're running microservices sounds good, but then again, in the real world, it really isn't. I was working with a company recently who at some point had so many sidecars, so they had one business logic, one container within their pod, and then they had 12, right? That's a dozen other sidecars running alongside that container. And it happened that way because throughout the years, they wanted to have a logging mechanism, and then somebody else came in on the team, and they wanted to have a different logging mechanism, and they didn't completely move away from one to the other, and then they want to have some additional caching, and then they wanted to, again, to have some service mesh for whatever communication with a service, and then there was another API they had to integrate, which required another sidecar, and all of a sudden, within 2 or 3 years, they ended up having one business logic, one container for almost every single microservice, and almost a dozen containers running alongside that. That's just crazy, right? Because that's, again, all that boilerplate code that you never touch and you never want to have your hands on or have your hands full with. And a bunch of other scenarios as these exist, actually, regretfully. So the whole idea is that Dapr, again, injects as a sidecar, but the benefit here, because I just mentioned that sidecars are bad, right? The benefit here is that you can have a single sidecar which actually leverages all of these capabilities, and then you ditch those dozen microservices or dozen containers that you wouldn't have had otherwise in your pods. So the idea is that it injects in as a sidecar, as a process, as a container on each of your compute units, and it just interacts with your application over HTTP or gRPC. You pick it. Okay, enough talking, enough slides. Let's actually cut to the chase. Let's work on some demos. Any questions so far? Go ahead. Well, the premise, I'm going to paraphrase your question if that's fine for the purpose of the recording and everyone else. The question was, why would you use a sidecar with a service mesh and Dapr at the same time? And long story short is, if you don't just want to replace everything with Dapr because maybe you're not sold on Dapr yet. So you're just going to use Dapr for some other responsibilities, right? Just extend the capabilities of your application with new features. And then at some point, you're going to say, okay, now it's time to actually ditch Linkerd or whatever else, Envoy or whatever you're using in favor of the capabilities which exist in Dapr. There might be features that you're using in Istio, for instance, that are not available in Dapr, right? And that could be a pitch for you using two different sidecars alongside with your app. But at some point, inevitably, everything can be done through programming. So I wouldn't see a reason why you would not want to have a single sidecar to support your application. Does this answer the question? Fantastic. Any other questions? You know, once I actually got a question from somebody telling me, hey, isn't Dapr dead? Because I've just learned that the program manager, Mark Fussell and Jaron Schneider, one of the senior engineers working on Dapr, were fired. Well, they left Microsoft. They weren't fired. They left Microsoft. What do you think about that? Am I pitching a technology which Microsoft is going to give up on? Because Microsoft does have a good history of some fantastic products that they gave up on. Silverlight, yeah, that's another one. They literally gave up on Silverlight. They didn't give up on Dapr though. Container apps, which I'm going to tell you about, actually natively integrates with Dapr. You remember Mark Rusinovich? He still is in the board for Dapr. But Dapr is a community-driven project. It was never Microsoft solely, right? There is a lot of community behind Dapr. And those two individuals, the names I've just mentioned, Mark Fussell, Jaron Schneider, they actually left Microsoft to found a company called Diagrid, which was a startup, and they got a Series A funding in November, unless I'm mistaken, of $24 million for supporting the products on top of Dapr that they're working on. And they're actively looking for new companies, even yourself. If you want to have a conversation with them, just let me know. They're eager to talk to you guys as well. And it's not just that, but they're on their board are people like Joe Betta. Ever heard of Joe Betta? Ever heard of Craig McLuckie? Ever heard of Brandon Burns? Ever heard of Google? Yeah? Ever heard of Kubernetes? So initially Kubernetes, which everybody knows unless you've lived under a rock, was written by 3 senior engineers at Google. Brandon Burns, Joe Betta, Craig McLuckie. Interestingly, none of them work at Google anymore. So they inspired Kubernetes on a product called Borg. By the way, I didn't know about you. I don't know if you knew about this, but people at Google, they're very much into, they're Trekkies, Star Trek fans, right? So Borg, you know what Borg is in Star Trek? Come on. What is Borg? It's a system, effectively, right? It's a robot system. It's an artificial system which has the purpose of annihilating anything which is organic-based, right? That's the whole idea. And you see it as a cube, that's their planet, vessel, whatever you want to call it. But there's a friendly Borg called Project 7. It was a female, a very good-looking female, who was friendly, who was working alongside with organic-based, well, I wouldn't necessarily call them humans, but that's a different conversation. So Project 7 was the code name for Kubernetes. If you look at the logo for Kubernetes, that's 7 spikes. Kubernetes, which is like a helmsman on a vessel, on a ship. No ship ever has 7 spikes. The Kubernetes logo has 7 spikes because that's a reference to Project 7. I told you, they're very much into Trekkies. So they inspired, the 3 engineers, Brandon Burns, Craig McCluskey, Joe Betta, working at Google, they created Kubernetes as an inspiration from Borg. They left Google. Brandon Burns is one of the senior engineers at Microsoft now. He's all the brains behind the operation for anything that has to do with management, ARM, Ansible, ARM, Bicep, you name it, as well as the entire containerization effort at Microsoft, including Windows containers and container support on Azure. Joe Betta and Craig McCluskey, they both work at VMware, and they're the heads behind VM Cloud, another cloud vendor, VMware, right? So Joe Betta is actually one of the leading board members and also the supporting individual of Diagrid. So there's a lot of smart people supporting Diagrid, which is the company supporting Dapr. So is Dapr ever going to go away? I don't think so. In my opinion, Dapr is going to create a revolution. And it's good for you to be here, actually, in this room and learn about it. So the first thing I'm going to show you right now is within this terminal here. Let me double check which folder I'm in. So there is a folder called order processor that I'm going to quickly switch over to. And the whole idea is that this is supposedly an e-commerce application. I have a microservice which is just going to process some orders, which could effectively mean I'm going to receive an order, remove stuff from the stock, send a bunch of payment integration signals, probably send some shipment messages and whatnot through a bunch of different APIs. And then I have a checkout microservice, which is simulating orders, okay? Super simple. So as with any project, so this is my order processor project. Don't worry, I'm going to zoom in a bunch. There we go. Here's my super duper complex business logic. So this is the entire program. And it is just mapping on the orders endpoint. And whenever I'm getting an HTTP request with the post verb, I'm just going to write on the console window, hey, I received an order, here's the order identifier, and that's it. Super simple, makes sense, hopefully. What's interesting here, however, is that there is no specific NuGet package for either Dapr or any other magical thing that would just have a bunch of things installed and which you would have to update every other week. I don't know about you, but if you ever have worked on microservices, one of the most daunting things, in my opinion, is NuGet packages. Because more often than not, you end up having this 50, 60 different projects within your microservices solution, and then there is a lot of inconsistency between the NuGet packages. And even worse, you go with the idea that, yeah, it's just a minor patch upgrade. I'm just going to do it without testing it thoroughly because it's a minor patch, right? So it is not supposed to break my application. And guess what? It breaks everything. And the worst thing about microservices is that because you don't have direct references and inter-process communication, but rather rely on API and HTTP or gRPC, there's no compiler to tell you that things would go wrong. So you have to actually run the darn thing, which is no easy task, right? So there's no NuGet packages here. I'm just relying on plain old HTTP. As long as your programming language is friends with generating an HTTP request, and every programming language should be, you're good, right? So what I'm about to show you here, super basic, super simple, is that just like any other .NET application, I'm just going to restore this guy. And then I'm going to build the darn application. Okay, so far so good. And now I'm about to run it. Now, your typical .NET approach when you're running an application is to say .NET run, correct? Now here we're going to Daprize the application. And they particularly enjoy this word because when you're in English, in British English, for the Brits around, dapper means that something is very good looking. Like my outfit can be dapper, or somebody could be looking dapper. I'm going to dapperize my application. I'm going to make it look good for this demo in particular. So what I'm going to do here is I'm going to call a CLI because every good tech has to have a CLI. I'm going to say dapr run, and then I'm going to specify a bunch of parameters, such as the application port going to be 7001, for instance. It has to have an identifier so that Dapr understands which application, how you call your application. So let's call it, for instance, order processor application protocol, because Dapr is going to communicate with my application over HTTP. It could also be gRPC. And then the Dapr thingy is going to listen for any incoming request on port 3501. And then I'm just going to separate all of the Dapr stuff with the command which actually runs my application. But I want you to picture that my application could have been, for instance, a Python app. Just replace .NET run with Python and you name your application, your Python script. Or maybe an exe, or whatever else, right? It's that simple. Anything can be Daprized effectively. That's the main pitch here. And it might be interesting to look at this verbose log, but I'm a developer, so it's just information. I don't care. But jokes aside, one of the things that you would see as a .NET developer, which might ring a bell, are the things in blue. Anything you see in blue is actually coming from the .NET command, the CLI command that I just ran. Everything else comes from Dapr. So this is a bunch of log, which tells me a bunch of services and middleware running within Dapr and communicating either with my application or just exposing stuff. So taking a couple of steps back, how does Dapr actually run? Dapr, remember the logo with the tie and the hat? Dapr actually looks and acts as a butler or a concierge in a hotel. Did anyone ever see Hotel Budapest? It's a fantastic movie. Anyone? Yeah? So in Hotel Budapest, I'm not going to share any spoilers, but the whole idea is that there is a shady network of hotel concierge people which get stuff done. So you want to order a pizza, they're going to get it done for you. You want to, I don't know, steal something from somebody, they're going to get it done for you, right? Dapr kind of acts in the same way. It doesn't really steal stuff. But the way it acts is that you're telling it things, and then Dapr figures it out and tells you back responses, such as, I want to communicate with this service. Your code doesn't have to know an IP address, a fully qualified domain name. It doesn't have to rely on DNS or anything as such. You're just telling from within your application, hey Dapr, can you talk to this app? And hence the reason why we have an application identifier parameter. And then Dapr, because it knows, because it's registered all of the other microservices or apps, communicates with the other apps, right? Just like any other service mesh service would do. So here I have my order processor, all up and running and chatty. Doesn't really do much. So the next thing I'm going to do is that I'm going to open up a new tab. There we go. And within this tab, I'll open up the checkout service. Let's look at the code for this one. Of course, it's on the other monitor, because why not? And then here's my code for that. So again, not too fancy. What I'm doing here is that I'm just looping through, I'm iterating through 1 until 10. This demo here would show that I'm not a proper developer because I started from 1, but you get the idea. And then I'm just generating a new object, which I'm going to serialize as JSON object, an order. The order specifically contains nothing more than a single parameter, actually, which would be, or a single property, there we go, which would be my order identifier. I'm just passing that along to the orders endpoint, which you saw previously mapped as an HTTP verb. Now, interestingly, is this base URL thing. And it's interesting because normally you would have an IP address of something that you would directly communicate with. But that would be cumbersome in a microservices scenario because your pods, they move around a lot. And thus, they have different IP addresses. So the solution would be inevitably to think about DNS. But then you come into new problems because DNS itself is a cache-based mechanism. It would have a time to live. Things would have to be constantly updated. It would also have to do a name resolution. It would, again, require a lot of time. So rather than doing that, the base URL actually happens to be the URL of, let me do this, of my Dapr port, which would either be something that I'm reading from an environment variable or the default 3500. Now, in this case, it would be 3501 because that's what's inside my variable, but just think about this. If I'm sending a message to the orders endpoint to Dapr, how does Dapr know which application it should communicate with? Again, this app doesn't know any IP addresses, but it does tell Dapr that there's an application identifier, specific order processor, which should receive this message, and that's it. So no special NuGet packages, just a plain old header, and that's about it. Super simple if you ask me. It's just back to the basics effectively. So let's run this application. And for the purpose of that, I'm just going to do a quick .NET restore, .NET build. And then as always, let me actually scroll here a bit. I would normally say .NET run, but I'm going to Dapprize the application. So instead I will say Dapr run application ID. Every application has to be identified with some sort of a name. Application protocol, HTTP. Oh, there's a typo. Protocol, HTTP. And then I'm going to say Dapr, HTTP port 3500, and that's it. So previously, when I Daprized an application, I also specified an application port. I'm not doing that here because this application doesn't receive any incoming messages, it just sends out messages. So Dapr doesn't have to send messages back to this app. Therefore, I'm not specifying an application port. But Dapr would receive or would communicate with this application itself. So therefore, I am specifying for Dapr an application. There's a typo over here. HTTP is wrong. HTTP would be correct. So now, on the right-hand side, I'm actually generating messages, and I'm sending them over to Dapr, and Dapr is sending them to this application, and you can see through the output that those messages are actually passed from one end to the other. And what's interesting is that if you would have multiple instances, Dapr would also have the capability of understanding and facading like a load balancing kind of a scenario where it's sending over toward the processor a bunch of messages, and it just balances out all of those messages to the many instances you could have. Or you could just send them to a single instance if you so choose to, and then just communicate with a single instance, but that's just crazy. I would never do that. Okay, cool. Impressed so far? Yeah, really? It's a super simple demo. Why? I'm kidding. What I do appreciate about Dapr in this regard is the simplicity behind it. And this simplicity actually drives further, in my opinion, the approachability and accessibility of Dapr. Because there's not a lot of engineering, there's not a lot of the steep learning curve, there's no NuGet packages. There are NuGet packages if you want, don't get me wrong. Let me actually show you another demo. So for the second demo, I will show you another capability, namely state management. So state management is all about this purpose of, let's figure out a place to store data at. I don't know about you, but I've been in some situations where we decided to hold data, which was just random stuff that would have been able to be stored anywhere. And back in the day, we decided to store it in SQL Server specifically. And then we went with the cloud, and that SQL Server got updated in the SQL database. And then we realized, hey, we wanted to have this, and we want to have that. So that at some point became a SQL managed instance for absolutely no reason, because that data could have easily been put in Azure storage accounts, and it would have been so much cheaper. Mistakes, right? We all do them. But at some point, you come across features and capabilities where you just need to hold some data, just some random data, right? Here's a question for you. Would you go with the implementation of a NuGet package specific for a technology within your code? Maybe, right? But that would also lock you in to that specific technology. It would not be easy to change that tag in favor of anything else if anything else new appears or if you want to move your code to a different vendor. Dapr has that. And I want to show you something really, really cool. So within this project here, again, an order processor scenario. This time around, it's just slightly more complicated. And I also have installed a NuGet package, because there are NuGet packages if you choose to. Namely, this one is Dapr ASP.NET Core. And what you'll see here, this is the order processor. I'm not going to show you the checkout anymore. This order processor doesn't only output a console write line, but instead it receives the order, and then it says, see that Dapr client thing I have at the top there on line 14? This one right here, right? And there's also a variable string called Dapr store name, called state store. Remember this one. It's gonna mean a lot later on. So with this client, I'm actually going to call a method called saveStateAsync. And then later on line 26, I'm saying getState, and then I'm also saying deleteState. State is used as a generic noun. It could be document, it could be entity, it could be tuple. These other nouns I've just mentioned are very specific to the kind of the technology you're using. Relational, non-relational, what kind of a non-relational is it? Is it document-based, key-value-based, yada, yada, yada. There's a bunch of different technologies for storing data. The way you store the data and the way the data is actually written underneath the hood on the magnetic or solid state differs on the technology. But state is just this generic noun for entity, for instance, right? It's the same thing. So what we're doing here is that we're storing data in a place. Now, if you were to take a guess, underneath the hood, where do you think I'm storing the data at? Is it SQL, Redis? I've heard Redis, Azure Storage, Amazon's S3. The reality is that it could be anywhere. And the beautiful thing is that I don't have to change a single line of code. It just is as it is, period. I can just change everything. Let me show you. So going back to the iTerminal window, just to prove that this actually works correctly, fingers crossed. You know, just prior to any presentation, whenever I have a lot of demos to show, and I do have a lot of demos because I told you 2 hours, I usually sacrifice the production virtual machine in favor of the demo gods, and I haven't done that, so it might be a bit daunting. Again, I'm going to run .NET run Daprized. So let's say Dapr run application ID order processor. And now I'm going to specify a new parameter that you haven't seen before. Components path. And I'm going to explain this one in a bit. So there's a special path here. Components. There we go. And then .NET run. Yoo, I did this correctly. So what you're about to see is that it loops through that iteration from 1 to 10. It creates an order, reads the order, deletes the order, waits a bunch, creates the order, reads the order, deletes the order, and so on and so forth. It's going to do the same thing over and over again up until 10. Let's just kill that, and let me show you something really cool. So you saw that folder previously, right? Let's open that guy up. So that's components. There we go. So I've opened this guy up in VS Code. Of course, it did open on the other window, because why not? And there's a YAML file. We all love YAML because, I don't know, it's the new thing in town. So if you're familiar with Kubernetes and AKS, you feel right at home. It has its own namespace, Dapr.io, v1 alpha. Don't be fooled into believing that Dapr is alpha and it should not be used in production. Actually, Dapr was production supported ever since version 0.4. And right now they're up to 1.10. Or 1.10 is just going to come up actually next week with a bunch of new features. So if you've been following Dapr, it's definitely worth looking at the community stand-up next week. But what you see here is a component kind of a component. Sounds fishy. Which has a name of state store. Remember the parameter I used previously in C#? State store? So this is the place where I'm defining where my data will be stored at. And sure enough, it is in Redis. This Redis happens to actually run localhost. So this means that I have a container running Redis where I'm storing all of my data. But imagine that at some point your manager comes in or a team leader comes in and says, let's see how it would be if we would store our data within Azure Storage. You know what I would have to do? I wouldn't have to install NuGet packages, just change this file. The whole change I would have to do would be this. Done. Just like that. Isn't that cool? It's pretty amazing. Now, I know what you're about to say. Okay, but what about using relational storage when we're running queries and we have a bunch of transactions and store procedures? This is the kind of abstraction where you don't ask that kind of questions, right? Because when you're very specific with your queries, rather than doing a point read operation where you know the identifier of the document, then you're looking at a different kind of technology. But here, I just want to have a bucket of data, right? And I'm just reading from that bucket because I know the unique identifiers, like the partition key, row key combination kind of thing. Make sense? Cool. Now, I only have so much time left, and I want to show you a bunch more. And I promise you I have a lot of demos. I was just about to use another word, but I'm recorded. Interestingly, however, is that I've actually taken this up for a notch. kubectl, get services. I want to show you a Daprized-based application. You know, I told you I'm a geek, right? So I geeked out with Dapr a while ago, and this is not a demo I wrote myself. I've just improved it a bit. It is a web-based version of a calculator, of course, because everybody needs that. And not only that, but it is running on Kubernetes, on AKS specifically. And this Kubernetes cluster, which is just running this app, has a system node pool, of course, with free virtual machines, and the user node pool, of course, with another free set of virtual machines. So I have 6 VMs running this app. Isn't that amazing? It's cool. And I really wanted to take advantage of the marketing pitch that Dapr has. Any language, any framework. So I decided that the division operation would be in Node.js, the multiplication operation would be in Python, the subtraction operation C#, whatever else for the addition, and then the entire UI is based on React. And so I have a bunch of containers, and they're all communicating with each other. And of course, the application runs. You saw that number you had there previously? Of course, I'm using state store. So whenever I'm opening up the app, it reads from Azure Storage whatever value I have had last, just in case you accidentally close down the tab and you wanted to see what the result was. This does run, right? But you know what's interesting is also the way these services, microservices, communicate with each other. Because they all communicate with HTTP and a bunch of gRPC as well. Because that's what you do in microservices. And there's a lot of service invocation and a lot of pub/sub, because I also have a bunch of pub/sub demos as well. But I realized that, well, I'm always a bit security concerned. I didn't tell you this before, I'm based in Romania, right? I still live in Romania. There's a lot of security stuff happening in Romania. Not necessarily the good things, but the bad things as well. So I wanted to have MTLS implemented. You know about SSL, right? The certificates thing. You all hate it because they expire at some point, right? You forget about it. We all do. Honest mistake. TLS is the newer version thing of SSL. It also has 4 different versions. Everybody uses 1.2. It's good enough for now. There's also another thing called MTLS, mutual TLS, which is like double trouble. If TLS sucks, mutual TLS sucks twice as much. Because certificates expire both ways, so you have to renew them in 2 places. So I decided that I would have MTLS implemented for the fun in every single microservice, so they all communicate and they handshake upon a certificate. But to make things interesting, because I'm a geek, I decided to have them expire very quickly and have Dapr renew them also very quickly. When I say very quickly, like how often do your certificates expire? Every 3 months? Every 12 months, yeah? So I decided I would go with 10 seconds, because why not? The cool thing is that over here, the application runs, renews certificates, communicates, does state management, everything else. Obviously, it's an over-engineered, geek-out thing that you would never do in the real world, but it does prove a point. And the point there is that you could have this technology based on Dapr, which takes you away from running any boilerplate code. Now, for the next hour, which I do not have, the next pitch would normally be around ACA, but a lot of you already raised your hand. So the idea about ACA, for those of you who are not familiar with it, Azure Container Apps for the long run, for this acronym, is that whatever you hate about Kubernetes is actually managed by a platform, namely Azure Container Apps. Many of you probably have heard of Azure App Services. Raise your hand if you did. So App Services has this idea that back in the day, it was leveraging Internet Information Services, IIS. How many of you have ever heard of IIS? How many of you love it? Nobody does. IIS sucks. But App Services, however, fantastic product. So App Services was actually abstracting IIS. And you never touched IIS anymore. ACA does the same thing with Kubernetes. You never touch Kubernetes anymore. And the pitches and the similarities are amazingly interesting. Because if you have an app service plan, like your server, you have an Azure Container App environment, which is the same thing, like a plan. On top of your plan, you're running your app services, which are your apps. On top of your environment, you're running your container app-based applications. And these can be containers, or it can be any Java app, .NET app, which is just going to say container app up, like with the Docker Compose thing, and it's just going to create a container on the spot for you, because there's a CLI, of course. And effectively, it is the new kind of platform, ecosystem-based platform, to run things on Azure. And the mindset when they created it, in my opinion, the best pitch for ACA is literally its history. They started from the idea that they wanted to create a product that would leverage scalability out of the box and would take you away from all the boilerplate code that you would have to work with Kubernetes if you would double down on Kubernetes. So ACA, in my opinion, is the proper path to go on from this point onward, and it is natively integrated with Dapr. And together they create the perfect bondage and the perfect marriage. And I will just tell you offline everything else. But I'm on time. If anyone has a question, like a burning question right now, I think we can still manage for 30 seconds another question. But other than that, yeah, there we have one. Yeah. Yeah. Akka, Orleans. Yeah. 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 And regretfully, hmm yeah. And it's still going. Yeah. Yeah. I didn't mention this before. I'm taking questions, but not difficult ones. Jokes aside, I will quickly paraphrase this for the purpose of the recording. There is actor support in Dapr, right? That's what you're saying. How much similarities do we have between Akka.net or Leans or any other actor-based technology and the actor support in Dapr? Regretfully, none, right? It's a new write-up of the actor-based model. Conceptually, they work the same, but you cannot just take your Orleans code and move it over to Dapr. One of the reasons behind it is actually, historically speaking, the actor support in Service Fabric has been completely written from ground up to begin with as a stateful-based model, and that's what Dapr is based on. But it's a programming language-based model. You can still write full actor support. You can decide to hold your data and your state whatever you choose to because of the components capability and the abstraction. But other than conceptually having a lot of similarities with Orleans, there's not much more to it. But it does run in pretty much in the same way. That's not to say that Orleans is ever going to go away, at least not in the near future. The team is rock solid, and they're kicking and they're going forward. They're making great stuff. Yeah. Thank you a lot. I'm going to be around for any more questions. I saw that you raised your hand. Thank you for that. Let's take it offline. Thanks.